Hello mathematicians, we're going to take a look at the components of a vector. So if we look at our vectors here, u and v, which we've previously added together, then we've noticed that the graphical method of vector addition and subtraction, if we did it carefully, could be really tedious because we have to shift the vectors around, draw them accurately, get their angles correct, and use scale factors. So often it's easier to add or subtract vectors algebraically by representing the vectors in terms of their components. Now any vector can be broken up into components, and a vector in two dimensions can be resolved into two perpendicular components using a little bit of trig. Generally in maths we'd refer them to the x and y axes, but in applications we might refer them to some other set of perpendicular axes. So if we look at our two vectors here, we could imagine breaking the vector v, for example, up into a horizontal component, v of x, and a vertical component, v of y, and likewise for the vector u. And you can see that vx plus vy using the parallelogram method gives us v, and ux plus uy gives us u. So it's sort of unadding the vectors in a way. So it's nothing new. We're just going to use basic trigonometry then to recognize the fact that what we have is that ux will equal the vector u, the magnitude of the vector u, times cos of alpha, and uy will equal u times sine of alpha, and similarly Vx will be the magnitude of v times cos of beta, and Vy will be the magnitude of v times sine of beta. And the angles, again, are given by trig. So alpha is tan to the minus 1 of uy on ux, and beta is tan to the minus 1 of vy on vx. If we look at the diagram, we can see that Vy will be negative because beta is below the horizontal. And always the magnitude could be reconstructed by using Pythagoras, that the magnitude of u is magnitude of ux squared plus the magnitude of uy squared. Now, once we've resolved those vectors into their components, then adding the two vectors can be as simple as just adding the components in a given direction. So u plus v could be the x components of u plus v added, and then the y components of u plus v added. So that would be 3 and 6 when we resolve those components, 3 plus 6 in the x direction and 3 plus minus 1 in the y direction, which altogether is 9 in the x direction and 2 in the y direction. And this is definitely not standard notation. This is just to point out the fact that all we're doing is adding the distances in the x directions and the distances in the y direction. And we can see that that gives us the same result as adding u and v graphically, which is of course what we'd expect. If we wanted to give the magnitude of u plus v, well then we're going to use Pythagoras, so it's the square root of 9 squared plus 2 squared. And if we wanted to give the orientation of u plus v with respect to the positive x direction, it would be tan to the minus 1 of 2 on 9. Now, we can also simply take components by observation if we have that possibility, or if the column form of the vector is given, use it directly. So vector u, we can see from the column form, is 3 in the x direction and 3 in the y direction, so we can write it like as shown. Similarly, vector v is in column form 6 minus 1. So when we add those two vectors, we again simply add the x components and the y components. So as we can see, as we've discovered already, that means the head of u plus v will be 9 units in the x direction, 2 units in the y direction from the starting point, from the tail of vector u in this case. Now we can also, so this is yet another method, make use of direction vectors in the form of unit vectors. Our unit vector is simply a vector of magnitude 1, and it points in a particular direction. So in the x, the y and the z direction, for what they're worth, the unit vectors are known as I, j and k. So they have a magnitude of 1. To get the actual unit vector, all that we do is take the vector and divide it by its magnitude. So we can see then that in column notation, the unit vector for the x direction is I, which is 1, 0, j is 0, 1, and the purpose of unit vectors is simply to indicate direction. So coming back to our original problem, instead of writing u in column form as 3 and 3, we would write it as 3i plus 3j. So translates as 3 in the x direction plus 3 in the y direction. And v is 6 in the x direction and 1 in the negative y direction. Add those together, 9i plus 2j. So once again, we get the same result as expected.